Okay, so I'm hoping this orientation will be a little better. We'll see. Sometimes it just wants to get blurry. So bear with me here. We're going to switch gears today, and we're going to find segment lengths in circles. To find segment lengths in circles. So, you guys know we just finished up angles, and there was 4 rules for that. So if the vertex is at the center, then the angle is equal to the arc. If it's on the circle, then the angle is half the arc. If it's in the circle, then the angle is half the sum. And if it's outside of the circle, then the angle is half the difference. So these are your angle rules that you want to really store in your head, okay? Now we're going to move to our segment rules. So it's the first one's called the chord rule. So when you have 2 intersecting chords in a circle, each segment is divided into 2 segments, and these are obviously called segments of the chords. So if 2 chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. And we actually just a real quick name for this, we call this part times part equals part times part. So if I'm looking at this example, that would be AE times EB is equal to DE times EC, and you would be done. So it's a pretty simple rule. So if you look at this one, I'm like, okay, oh, can you see that? There's 2 chords. And so I'm going to say that I'll go backwards here. So x times x plus 5 is equal to x plus 3 times x plus 1. So this is part times part equals part times part. So over here, when you distribute the x, you get x squared plus 5x equals, we're going to double distribute here. So x squared plus 1x plus 3x plus 3. And we notice at first this looks like it's going to be a quadratic, but since you have an x squared on each side, those are just going to cross out. And so we get 5x equals 4x plus 3. Subtract your 4x over, and x is 3. Now be careful. This is geometry, so typically x is not your answer. So for this particular problem, they want us to find ML, which has an x plus 1 plus an x plus 3. So I'm just going to plug my 3 in for x. So I get 4 plus 6, so ML should be 10. And then for JK, it's x plus 5 plus x. So that's going to be 3 plus 5 is 8. Plus 3 is 11. And that is how you do part times part equals part times part. Again, that's for a chord. I'm really hoping my camera battery doesn't die, but we'll see. All right, so the next thing that could happen is you could have 2 secants. So we call this one a secant. So it says if 2 secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment. So what do you think this word external means? Right there. That's going to be outside. So equals the product of the lengths of the other secant segment and its external segment. So here's what we say for this one. External times whole, be very careful about that, equals external times whole, meaning you've got to get the whole secant for that second part. So in this picture, it would be EA times the whole thing. EB equals EC times the whole thing, ED. So for our example here, we see that it's a secant. So I'm going to take my outside part times the whole thing. So external times whole equals external times whole. Now for the whole, I'm just going to write this out as 6 plus 4. You can obviously probably add that in your head. And if you come down to this side, that's the external part, but the whole thing would be 5 plus x. And you do have to write that out. So we get 6 times 10, so it's going to be 60 is 25 plus 5x. Subtract 25 from both sides. That's going to give me 35 equals 5x, and x is 7. Again, I don't know why these notes are doing that, but that should say find the value of x. So on this one, we don't need to plug it back in. We are finished. Okay, and then the last one today is called the secant tangent theorem. And so this says if you have one secant, so that's obviously going to touch the circle twice, and then one tangent that only touches it once, then it says they share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So when you have a secant and a tangent, the rule is that the tangent squared is equal to the external part times the whole. So again, I'm going to come to this problem. I'm going to go, oh, that's a tangent. That's a secant. So it's tangent squared equals external times whole. So my tangent is this 8 right here. So 8 squared is equal to my external part, which is x, times x plus 12. So we get 64 is x squared plus 12x. When we distribute that x right there, we realize this is a quadratic. So I need to get this side equal to 0. So 0 is x squared plus 12x minus 64. And obviously we want to try to factor it first. So we start kind of going through all the factors of 64. And then 16 and 4. So you need positive 12. So we need positive 16, negative 4. Will get us a sum of positive 12 and a product of negative 64. Oops, so let me come over here. So 0 is x plus 16 times x minus 4. So the negative 16 is not going to work because it can't, like that little segment cannot be negative 16. So x must be 4. Now notice it did ask for rs, which just has an x on it. So that is the same answer. That's it. Oh shoot, I just noticed that was blurry. I'm sorry. Can you see that? I hope the whole thing wasn't blurry. And then the last page of your notes is just just a bunch of examples. So I think I'll let you try this page. I'll post the answers. That could be your practice. And then I'll also post your homework for this section of notes. So far you guys are doing a great job. Just please let me know if you have questions. I'm going to try to figure out Google Meets here someday soon. And hopefully we can meet up on there. Talk to you later. Bye.